Hey guys, it's Miss Johnson, and I'm here to bring you the second half of our notes video for today, where we are talking about factoring trinomials. So factoring trinomials, we did a whole bunch of examples yesterday, and today we're going to talk about two unique cases and do a bunch more examples. So two unique cases of factoring trinomials is when we have a greatest common factor, which we did actually talk about a little bit yesterday, and we saw one example about how we pull that greatest common factor out first. But then the other one is when we have one that's relatively prime. And what I mean by relatively prime is, let's say we have two numbers like 15 and 8. Now, these two numbers in and of themselves are not prime. 15 has factors of 3 and 5, 8 has factors of 2 and 4, so they're already not prime numbers. But with relation to each other, the factors of 15, 1, 3, 5, and 15, the factors of 8, 1, 2, 4, and 8, they have no common factors other than 1. That's what makes them relatively prime to each other. So we're going to have some relatively prime trinomials that will then be not factorable. Relatively prime trinomials are not factorable. Now we have to be really careful before we jump to the not factorable conclusion. We need to exhaust all our options and make sure we've really checked. Okay, so let's take a look at number 9. In number 9, I have 4r squared minus r plus 7. I have no GCF to take out, so I'm just going to start by setting up the factor x. When I set up the factor x, this is my a, this is my c, so 4 times 7 is 28. The middle term is going to be a negative 1. There's a 1 in front of that r there. So then I take a look at numbers that will multiply to 28. So if I think about numbers that multiply to 28, I have 1 times 28, 2 times 14, 4 times 7, and nothing else. But then I could also do negative 1 and negative 28, negative 2 and negative 14, and negative 4 and negative 7. All of those products will give me 28, positive 28. Now let's go back and figure out their sums. This one's 29. This one is 16. This one is 11. This one is negative 29. This one was negative 16, and this one is negative 11. So when I look through that list of sums, I don't have anything that gives me a negative 1. Therefore, there are no factors that multiply to 28 and add a negative 1 at the same time. This one is not factorable, or in other words, relatively prime. So this is a trinomial that is relatively prime, meaning there are no terms that I can break it up into factored form. Okay, so let's look at number 10. In number 10, I have 10y squared minus 35y plus 30, and I need to start by finding my GCF. So I notice that there's a 10, a 35, and a 30. Those are all divisible by 5. So I can divide out a 5 from all of them. I can't take a y out because I don't have a y over here with the 30, but I can take out a 5. So I'm going to put my 5 out front and see what that leaves me with. That's going to leave me with 2y squared minus 7y plus 6. Now I go back and factor the trinomial that's left over. Okay, so now when I set up the factor x for the middle, I have 2 times 6, which is 12, and I have a middle term of negative 7. And then when I think about what multiplies to positive 12 and adds to negative 7, that means I'm going to need a negative 3 and a negative 4. Negative 3 times negative 4 gives me positive 12. Negative 3 plus negative 4 gives me negative 7. So x, x, there we go. So now I split this middle term. I have a 5 out front. I keep, well, actually, we can ignore that 5 for right now. Let's go ahead and ignore that 5 for right now. We're just going to work on the trinomial in the middle. And again, like I said yesterday, if it helps you, it helps me to circle it and draw an arrow down to the bottom so I remember to put it back on, then go ahead and do that. So when I rewrite the middle, I have 2y squared minus 3y, and I guess these should be y's, not x's, minus 4y plus 6. So then group and group I have a y that I can take out of this one. So I have y out front, 2y minus 3 behind. From the second group, I have a negative 4y plus 6. I know I can take out a 2, but since the first term's negative, second term's positive, I know I need that 2 to be negative because I want a positive, then negative. So I'm going to make that a negative 2 out front, which gives me positive 2y and then minus 3. Same, same. I have y minus 2, 2y minus 3. My 5 goes back out front from the original GCF, and that's my factored form. Let's take a look at number 11. In number 11, I have 3x squared plus 24x plus 45. I need to take out a 3. I have a GCF of 3 that can come out of everything. So if I pull out a 3, that means I have 3 out front times x squared plus 8x plus 9. Now, taking out that GCF is really going to come into handy when we start solving quadratics because it's just a whole lot easier when we have a smaller trinomial to work with. So now let's set up our factor x of 1x squared. So 1 times 9 gives me 9 on the top. Middle term is 8 on the bottom. And then I have a positive. Okay, let's back up because I am not doing this right. 45 divided by 3 is not 9, it's actually 15. There we go. That'll fix that. So plus 15, that's a 15 on the top. That's what I wanted. So then I know I need a 3 times a 5. Okay, back in business here. So GCF is going to come down to the bottom. Rewrite the 8x in the middle using 3x and 5x. So I have x squared plus 3x plus 5x plus 15, hello, not 9. I was divided by 5 instead of 3. And then I will group and group. Take out an x, you're left with x plus 3. Take out a 5, you're left with x plus 3. You have x plus 5 and x plus 3 multiplied together. And then I throw my 3, which was my original GCF, back out on front. And there's my factored form. Okay, let's try number 12. I'll try to get it right this time. So in number 12, no GCF that I can take out of all of them. There's a 2 here and a 2 here, but not there. There's an x here and an x there, but not here. So no GCF. So then now I just set up my x. 1 times 2 gives me 2, and 2 on the bottom. Now let's talk about things that multiply to give me this product of 2 on the top. So when I multiply to get to 2, it's 1 times 2. That's my only option. I don't have any other options that give me, well, I guess you could say -1 and -2. When I add 1 and 2, I get 3. When I add -1 and -2, I get -3. This is one that is not factorable. So we call this relatively prime. All right. Let's flip over and go to number 13. In number 13, I have 10x to the second minus 43x plus 28. And I need to factor this. So the first thing I look for is a GCF. I'm pretty sure there's no GCF here. I can take a 2 out of 10 and 28, but I can't take a 2 out of 43. I'm pretty sure 43 is actually prime. So I guess that's how it's going to be. So I set up my factor x, and you're going to get some big numbers here, but that's okay. 10 times 28 is 280. We know that. Middle term, -43. So I know already, since I want a positive product and a negative sum, that these both are going to be negative. So that helps me. Then I just need to start dividing things into 280 and figure out what I get. When you start making your list, 280 is going to have a really big list, but we come to one that gives us a product of negative, or a sum of -43, and that's -35 and -8. So that's what I'm going to split my middle into. I have 10x squared minus 35x minus 8x plus 28. And then I group and group. From this group, I can take out a 5 and an x. So I have 5x out front. And I have negative 35 divided by 5 is going to be, oh, this one gives me 2x. This one gives me negative 7. And then the second group, negative 8x plus 28, I can take out a 4. But since this one started negative and that one started positive, I need the signs to flip. So I'm going to make that a negative 4 that I take out. And that does in fact work. Negative 8x divided by negative 4 is positive 2x. 28 divided by negative 4 is negative 7. So my factors are 5x minus 4 and 2x minus 7. Factored form. Now, some of you may be wondering what would happen if we wrote these in a different order. If I wrote negative 8 and then negative 35, am I going to get a different answer? And the answer is no. All it would change is that these would become your outside factors and the 5x minus 4 would have become your inside factors. So it does not matter which order you split this middle term into. I could have put the negative 8x there and the negative 35x there, and I would have gotten the same answer. All right, let's try number 14. In 14, I have 2x squared plus 5x minus 2. No GCS to take out, so let's check the factoring. 2 times negative 2 is negative 4. Middle term needs to be positive 5. So to get a product of negative 4, I need to multiply 1 times negative 4, or 2 times negative 2, or negative 1 times positive 4. When I add these up, I get a negative 3. There I get 0. And here I get a positive 3. None of them give me a 5, so this one is not factorable, which means it is a relatively prime trinomial. All right. So let's talk about 15. X squared plus 3x plus 9. No GCF to take out, so let's just multiply. 1 times 9 gives me 9. Bottom term gives me 3. And then I would look for my options that multiply to 9 and add to 3. Well, 9 is 1 times 9 and 3 times 3, and that's it. Well, and negative options of both of those, but I want a positive sum. So when I add those together, I get 10. Add those together, I get 6. Nothing that gives me 3. This is another one that is not factorable. It's really nice when these things end up being not factorable because you're kind of done early and it saves a lot of work. But please be very careful and make sure you're exhausting all of your options that give you that product on the top before you decide that it's not factorable. A lot of people want to jump to conclusions, but they haven't really looked at all the options they have. Let's talk about 16. 16, I have x squared plus 5x minus 6. I don't have GCF to take out, so I'm just going to, that's why that would stay together, that's okay. So I'm just going to set up my factor x. When I set up my factor x, I have 1 times negative 6, which is a negative 6, and I have a positive 5 product. So I multiply, let's see what gives me a negative 6. What gives me a negative 6 would be something like 1 and negative 6, 2 and negative 3, or negative 1 and positive 6, and negative 2 and positive 3. When I add all those together, this one gives me a negative 5, this one gives me a negative 1, this one gives me a positive 5, this one gives me a positive 1. So my best option here is negative 1 and 6. So that's what I'm going to split my middle term into. X squared minus 1x plus 6x minus 6. And I'll group and group. So here I can take out an x, leaves me with x minus 1. There I can take out a 6, leaves me with x minus 1. And I'm left with x plus 6 and x minus 1. Now I want to take a minute to show you that it doesn't matter if I split the middle or if I switch the orders of the middles. If I would have switched these two and written them in a different order like this, x squared plus 6x minus 1x minus 6, I get the same answer. Here's how. So from the first group here, I can take out an x, leaving me with x plus 6. From the second group here, I want to take out a negative 1. So that's minus 1, leaving me with positive x plus 6. I end up with x minus 1, x plus 6. This factored form is the same as this factored form. Even though I wrote my x minus 1 in front, and here I wrote it behind, x minus 6, they switch places, we know that multiplication is commutative. I can switch the order of things that I multiply by. So this is really the same answer as that one down there. Does not matter which order you put them in. Okay, a few more examples left. 6x squared plus 5x minus 6, no GCF, so go straight to that factor x. 6 times negative 6 is negative 36 on the top. Bottom is that positive 5. So think about things that multiply to give you negative 36. My options here that add to positive 5 is going to be 9 and negative 4. So I'm going to split that middle term with 9x and negative 4x. So I have 6x squared. I'm going to put minus 4x second plus 9x minus 6. I like doing that because then I know my terms go positive, negative, and they're already set up the way I want them to look to take out a factor. So from 6x squared minus 4x, I am going to take out a 2 and an x. So 2x out front, meaning 3x minus 2 behind. Then 9x minus 6 divided by 3. I'm going to divide by 3 here. Oops, not 9, 3. And that leaves me with 3x minus 2. Same, same. 2x plus 3, 3x minus 2. Now, what I was saying before about putting the negative 4x in front, if I would have put the negative 4x with the 6, I would have needed to worry about taking out a negative here. And I like that my signs matched before I had to do the factoring. So that's just why I did it that way. But again, like we just talked about, you can switch this order and you get the same factored form. Okay, let's try 18. 6x squared minus 14x minus 12. Now I do have a GCF that I need to take out. So I'm going to divide everything by 2. I can take out a 2 from everything. So that 2 comes out front, leaving me with 3x squared minus 7x minus 6. And then I factor the middle. So set up your factor x. This 3 times negative 6 is negative 18, negative 7 on the bottom, which means I want a negative 9 and a positive 2. Negative 9 times 2 is negative 18. Negative 9 plus 2 is negative 7. So that's what I'm going to split this into. This is going to come down to the bottom. Keep 3x squared the same. Put in your negative 9x. Put in your positive 2x. Keep negative 6 the same. So remember, throw x's on those, split the middle. Group and group. From the first group, I can take out a 3x, leaving me with x minus 3. From the second group, I can take out a 2, leaving me with x minus 3. So I have 3x plus 2, x minus 3. Original GCF of 2 is out front being multiplied, and that's that. Okay, 19. In 19, I have x squared plus 6x plus 5, and I don't have a GCF, so let's just start by setting up the factor x. I want a product of 1 times 5, which is 5, and a sum of 6. So the only way I can get a product of 5 is using 1 and 5, and 1 plus 5 does give me 6, so this is factorial, and that's what I'll split my middle into. So I have x squared plus 1x plus 5x plus 5. And then I group them. Group and group. Take out an x, leaves me with x plus 1. Take out a 5, leaves me with x plus 1. I have x plus 5, x plus 1. There's my factored form. Last question, and then we get to be done with these notes. So in number 20, x squared plus x minus 2, no GCF. So I'm just ready to factor. 1 times negative 2 is negative 2, and middle term is a 1. So what adds to negative 2, I'm sorry, multiplies to negative 2 and adds to 1, multiplies to negative 2 and adds to 1 is going to be 2 and negative 1. So that's what I'm going to split my middle term into. So get rid of that. I've got x squared minus 1x plus 2x minus 2. And then I factor them. Group, group. I can take out an x, leaving me with x minus 1. I can take out a 2, leaving me with x minus 1. So I have x plus 2, x minus 1. Okay. That is going to conclude our factoring trinomials notes video. Now, factoring trinomials is a complicated, tricky concept. Don't be upset if it's still hard for you or if you're still confused. We will work a lot on it. I really want you to work hard on this practice and make sure that you're getting down what you need to get down, and we will go from there. Thanks for listening, and I will see you later.